Hello and welcome to this video. In this video, I'm going to be giving you a complete step-by-step guide on how to plan and build your next full stack application in 2024. This guide is evergreen and you can use it at any point in time to guide you in order to build your next full stack app. You can use what you learn in this video to build your next software as a service, that is your next SaaS, your next client project, or your next portfolio project. This is a complete guide that is going to take you at any point in time when you want to build your own apps or your own software, so you can use this as a blueprint in order to do that. So this is a raw video with no fancy editing, where we are going to go straight to the point and you are going to cover everything you need to know, including everything you should and you should not do when building an application. All the things you're going to learn in this video is going to save you a lot of time when building an application, so you shouldn't make the mistakes we did when we were starting out and when we're trying to build our own application by ourselves. So let's get straight into the video. So first of all, who am I and how can I talk so much about this topic? So let me just give you a little background about myself. So I am ATO and I actually started learning how to code a very long time ago, like over 8 years ago. But it's only until 2020 where I really started getting serious and taking my coding journey seriously and actually putting in the work, and from then till now, I've built several applications, built several client projects, and built several personal projects that I can confidently stack on my portfolio and use it as my experience. So here are just a few apps that I've already built, and I'll just show you these so you can actually know who I am. So this is the first full stack project that I actually built, and I built this one when I was just starting out. So I was just like 3 months into taking my programming journey seriously. So I was doing an internship at this time and I had an idea if I could build an app that people actually want to use. And this app is actually a very simple app. It's just a mobile money charges calculator, as you can see right here. And it just helps people know what transactional fee they need to use when trying to send money from several African countries. And this didn't get a lot of users, this didn't get a lot of downloads, as I was building it mainly to help me solve a problem. And that is also one of the main reasons I always recommend people to start building software, to solve your own problems before trying to make your solution available for everyone else. So I was building this project for myself and it was a very helpful project. I still use it till this day. So when I was starting out, I started learning React.js, and I was already learning Java in the university, that is in college. I was already learning Java. So I used my experience in Java in order to learn server-side programming with the Spring Boot framework. That is what I used in the backend for this project. So this was in 2021. This was in summer of 2021. I actually took about 1 week or 2 weeks to build this project. I took like a week to build the front end and another weekend to build the back end and deploy everything. So I was just starting out and everything was a little bit rough. I didn't really know a lot about designing. I really didn't know a lot about building back ends. So I was doing a lot of things wrong, but I finally got something and I was able to build and deploy the project. So the technologies I used at the time were React.js plus styled components, and that is for the front end. And for the back end, I used Java plus Spring Boot plus MariaDB. There wasn't really a lot going on in the back end, especially in the database, as I was just using the database to collect people's emails so I could notify them once the mobile app was going to be available. Because at the time I was building this app, I really didn't know a lot about mobile application development. I only knew front-end development with React.js, but I was planning to learn mobile application development. So a few months later, about 2 months later, I learned React Native and started building mobile apps with React Native. And this is the mobile version of the same app. This is the charges calculator here. And I also added a currency converter in the mobile application. All the backend was in Java and hosted in Heroku. The Heroku is basically a website where you can host your servers and your backends. So this was the first project I did. So after this, I did a lot of other little practice projects. And this other project was something a little bit bigger that I embarked on. Here I was having a team of developers with whom we're working. We're having a designer. So I was basically like doing project management on my own. So after leaving from doing fun projects by myself, I hired a couple of developers, and along with a friend, we started building a learning management system, which is called OraLearn. So if you've been following me on Facebook, you should probably know this software already. So this was a bigger project and a very much enthusiastic project that we unfortunately had to stop along the way, but it helped me learn a lot of things. It helped me learn a lot on how to actually plan and build software, why it is necessary to plan your software, design your backends correctly before actually starting to code. So this was the front end. As you can see, we had payment integrated into it. We had several currencies integrated into it using several different payment methods from several countries. As you can see here, Nigeria, you could pay even if you're living in Nigeria with a payments method called Flutterwave. And here, this is the Stripe integration. So everything was integrated into the project with Google Authentication. And the technologies we use here for the front end, React.js plus Tailwind CSS. For the backend, we use Node.js and Express.js. And then the front end was hosted on render.com. The backend was hosted on Heroku. And some external services we use for the database, we had Firebase, Firestore, Firebase authentication to authenticate users, obviously, Firebase storage to store images, Getstream. Getstream is basically a service that helps you integrate social media features like feeds and messaging. So this is the technologies we use. So this was the front end side, and this was the web app. We also developed a mobile app, which was basically like a social media application where people could actually come and grow their following, post a lot about programming, take lessons or free lessons and courses, and chat with each other. So I actually built the mobile app by myself. The web app was built by myself and a team, but the mobile app was entirely built by myself. As you can see, we ended up racking up like 1,500 people on the app, but it didn't really go anywhere. We really didn't push it any further. I think it's still on the App Store, if I'm not mistaken, or I've taken it down, but I can put it back up if anybody wants to see. But this is just to give you an idea of what I've gotten to do over the years. And these were projects I did a couple of years and a couple of months ago. So from there to now, I've already built several other projects, worked on other client projects for web apps and even mobile apps. So everything I've learned now, I'm going to be sharing it in this video. So you shouldn't make the mistakes I did when starting out, and you can go and build software or web apps or applications in general in the right manner and not take too much time doing all the mistakes I did. So this mobile app was built entirely with React Native, and the backend was the same backend we used for the web app. So everything was interconnected. You could log in with your same account on the mobile app and the web app and so on. So this is not all the applications I've built. I also built another AI app, and I don't want to share any client projects I've done here, obviously, because I don't have permission to do that. So I'm just sharing the ones I did. That is when I was learning and when I was trying to also deploy my own custom app. So this is just to show you what I've done over the years, to show you that I actually have a lot of experience in building apps. And right now, I'm now venturing into building SaaS, and I'll be sharing everything I learned along the way here on my YouTube channel. We have covered who am I, how I can talk about this topic, and what I have built. So now that we have established that, let me show you now how you should go about building your own full stack applications. Take note that this video is not something that I went and just did research. This is from my own personal experience. So there are other ways of doing the same thing, but I made this video because I don't see a lot of videos on the internet like this, especially when I was trying to build my own apps. I didn't really see a lot of guides who were guiding you on what technologies to use, how to go about designing, whether you should start on the front end, on the back end. That is why I decided to do this video, so it can help people who are in my situation, who didn't know where to start, where to go to, and how to go about building apps. So everything we're going to cover here, if you are an absolute beginner, you are someone who has a little bit of experience, or you are having a lot of experience and you want to see just a different way of doing things or another way of doing things, this video is absolutely for you. So you can tag along and watch till the end, so we cover everything we have to cover. So firstly, when you want to build your own full stack applications, you first have to start with the idea. Because I see a lot of people, when they have an idea, they go straight into coding. They open their code editor directly and they want to start coding. That is what I was doing before, but I don't do that anymore because I understand fundamentally that as a developer or as a software developer, your ability to think is directly related to how good the code you're going to write is. So if you cannot think well, you cannot really write good code. And in order to think well, you need to put down your ideas on paper. You need to spend a lot of time doing research and analyzing if the idea you want to build is actually legit or not, or if the tools you want to use are actually the right tools or not. So you have to start with the idea. You do a lot of research. You ask yourself, should I build it? Because there are certain ideas that are not worth building. You actually waste your time and you actually just take you to nowhere. So if it's yes, you do more research. You don't go straight into building it. If it's no, you still do more research and think more about your idea or change your idea indefinitely. So if you decide to build it, The research you're now doing now is not on the idea, but it's now on the technologies and the tools you're supposed to use. Because the technologies and the tools you're going to use are basically going to make or break your project. There are certain technologies which are more suitable than others depending on certain conditions, and sometimes you should use the technology if you're already familiar with it to begin with. So we are going to look into all that right now. So as a solo full stack developer, there is always this question that arises: should I start with the front end or the back end? And as a full stack developer, generally, especially if you're just starting out, you usually be tempted to start with the front end. And this is something that I was doing a lot when I was starting out. I was always starting with the front end because it was just better for me to be able to visualize what I was building before starting to actually build the functionality. And though this was fun and this was really giving me a lot of motivation to keep building the project, because when you're able to visualize how the user is going to use it, it's pretty exciting and you think that you're actually doing the right thing. But this is absolutely the wrong way to go. Never start with the front end. Never start by building the front end, or you're going to spend a lot more time trying to hard code values, trying to make things look the way they're supposed to be without the actual data than you want to. So starting with the front end is actually going to be detrimental and it's going to make you build your components in the wrong way. So never start with the front end. Next question is, should you start with the backend? You shouldn't also start with the backend unless you already have a very fixed idea or very fixed blueprint in your mind on how you want your app to be and how you want your app to work. You shouldn't also start with the backend. Why is this? Because if you start with the backend without actually visualizing how your app is going to look and feel, you might actually get stuck after building the backend in trying to build a good user interface. So the main way I recommend is by starting with the UI UX design. So you should actually design the app in a tool like Figma or Adobe XD, so you can visualize how the app is going to look for users. Because at the end of the day, your app is your business logic, but what makes or break your app is how easy it is to use, the user experience, the user interface, and what the user actually sees and how the user interacts with your app. That is actually what differentiates between a successful and an unsuccessful app. So as a solo developer, because this is for a solo developer, if you're working as a team, that is a whole different thing. If you're working as a team, it is better to start building the back end, or you can even build both simultaneously. You start designing the front end with the UI UX, and then you can also start designing the back end with all the relationships and so on. But as a solo developer, what I recommend and what I've seen after making a lot of research and after building a lot of projects is that you should start building the UI UX. So you should start building the user interface. And if you're a solo developer, you started out like me, because when I started out, I wasn't having any designer, I wasn't having any team, but now I do. So I have a designer on my team who designs my apps before we go ahead and build. But I was starting by building the UI UX myself. And how was I doing this even without having experience in UI UX designing? So tools like Figma and Adobe XD are very easy to use. I highly recommend Figma because it's free and it's still easy to use. And the way you take to get inspiration for your app is by going through this website where people always post their designs for free. Like there is Dribble I use a lot, so dribble.com and behance.com. So I basically go to dribble.com and behance.com, try to look for projects that are similar to the one I want to build, take a lot of ideas and just try to build my different screens using those designs I've seen. This step is very crucial because it actually helps you visualize the idea and actually helps you see how the app is going to look like before actually starting to build it. So I highly recommend you spend a lot of time doing research and building the UI by yourself. If you can hire a designer, that is fine. But I know a lot of people who are starting out or people who just want to build projects for themselves. They don't really have a team, so it's very necessary to know how to design stuff by yourself. And all these apps are very easy to use. Figma is easy to use, and you can always get inspiration from here. So this helps you brainstorm your ideas. And as I said, thanks to Figma, you can actually start putting your design and putting your ideas in actual design so that you can know how the app is going to look like before starting to build your app from scratch. And after you've come up with the design, you should not go straight to implementing the design. Don't do this mistake. Don't go straight to coding everything and implementing the front end. You need to start designing your back end. So basically, you already know how your app is going to look and feel. You already know what the user is going to see. Now you need to go to the main part of your application, that is the business logic. As the word implies, business logic, that is basically what your app is about. Your app is the back end, your app is not the front end. How it's going to work, how data is going to interact with each other is happening in the back end. So before you write your first line of code in the back end, you have to start by designing it. This step might sound very basic, but trust me, solo developers always make this mistake of not taking time to actually design their backend and design their apps, and they just want to go straight to coding because, well, they're alone. Nobody's holding them accountable. They don't need to report to anyone. But this is going to save you a lot of time. So you have to design your backend, because in the long run, you save you a lot of time. In the short run, it's going to seem like you're wasting your time. But in the long run, trust me, you're going to love the fact that you actually took time to design. So I don't remember where I heard this quote, but it really stuck with me. So developers should spend less time coding and more time writing. Ideas happen in the thinking, not in the coding. So if you go straight into coding, you're not actually spending time thinking about your ideas. You're not actually spending time solving problems. You're just implementing. And nobody solves any problem. Nobody comes up with any solution by implementing. Solutions comes up in the thinking. And in order to think, you need to write down your ideas. And designing the backend is a way of writing down your ideas and how data is going to work. How do you design the backend? So when designing your backend, you need to look at the requirements of your application. If it's a very complex application which needs several services, you can go with what is called microservices. If it's that you have a few services and you just want to launch your backend quite fast, keeping in mind that whenever you want to scale, you have to scale vertically, then you're going to go with a monolithic architecture. So both are still good, both are very good. I always recommend, as a solo developer, when starting with a small project, always start with a monolithic architecture, because first of all, it is cheaper to run than microservices, because microservices are basically running several servers or several services that are interacting with each other independently, whereas with a monolithic architecture, you're putting all the services in the form of modules. So for example, if you're using Java as your backend, every service is a class. If you're using JavaScript, every service is a new file. So everything is just in the form of modules, and you can expose the APIs individually in each module. Whereas as microservices, every service is hosted independently of the other. Then you can use a messaging system like, maybe let's say Kafka, to ensure the communication between all services and ensure that the data is actually being transmitted seamlessly. So microservices are actually more complicated to implement than monolithic architecture, and I highly recommend, as a solo developer, when starting your first project or your first big project, go first with a monolithic architecture, and then later on, if need be, if you really need to scale more horizontally, you can go with microservices. Monolithic architectures are still really good and can still hire a lot of users. I even think that recently there was one of Amazon service. I don't know if it was Amazon Music or Amazon, anything on Amazon. They actually switched from a microservice architecture to a completely monolithic architecture. I didn't really read in detail why was that, but if you see a big company with billions of users like Amazon switching from microservices to monolithic, it means that one is not actually better than the other. It just depends on your use cases. And most of the time, monolithic architectures are easier to implement than microservices. So when you're starting out, I highly recommend not even looking too much into the microservice department. You should go straight into a monolithic architecture. Vertical scaling is easy with this. Vertical scaling just means that adding more hardware in order to scale. For example, if you're hosting your project on, let's say, AWS, you're just basically adding the RAM, adding the processor speed, and then you're scaling because it's going to be fast. It can allow more concurrent users and allow a greater load. You can also scale horizontally by multiplying the number of servers. So decide between monolithic or microservices. I highly recommend starting out with monolithic because that is always what I start with. So this next point is just for you to be able to visualize your backend. So I always use diagrams in order to visualize how my data is going to be transferred. So I make sure to explicitly state that I'm going to have a mobile app or a web app which is going to be connected to these different services, which is going to be connected to this database, and so on. So I make sure to visualize it, and I use this current software that I'm using called Miro. And this helps you really create diagrams and really create data flows, flow charts, entity relationship diagrams for all your stuff. So the next thing you need to do is to select your backend language and framework. So I personally, my choices are not very large when I want to build my backend. I always choose between Java and Node.js. And the choices depend on several conditions. because I don't just start programming just like that. I don't just pick a random language and program. If I really want to get something out fast to the public, I use Node.js. I know that Node.js, you can actually bootstrap something real quick and start testing your APIs in less than an hour. Whereas with something like Java and Spring Boot, it's going to take you a greater amount of time to achieve the same results. And there's a lot of things that go into setting up and stuff. But I know that when I want to build something that is going to be more complex, I want to have more granular control about every single thing. I know I'm going to go with Java and Spring Boot. So you can choose either, but if you're having experience in several different programming languages, you really need to do research on which programming language is suitable for what you're trying to achieve. So Node.js is more lightweight. Java and Spring Boot are less lightweight. It takes more RAM on your server, but it allows for more complex architecture, more complex design, and it's just easier to set up for certain things than Node.js. And also, Java's object-oriented nature is very suitable for complex applications. So you need to take all those into consideration when picking a language for your backend. So your choice is obviously going to depend on various conditions, and you also need to determine additional requirements for your project and especially external integration. For example, something like JavaScript or Node.js have a lot of SDKs implemented for it. So a lot of external services have their SDKs already built for Node.js. Whereas something like Spring Boot, there are not a lot of SDKs, so you always have to implement the APIs from scratch by yourself. Whereas with the SDKs, you can just install the packages and just use the classes already provided by the API builder, for example. So this is something you should also take into consideration when trying to pick your programming language. Node.js is actually very easy with the packages and the SDKs, but JavaScript, on the other hand, a lot of developers don't really build their SDKs for JavaScript. So I realized this a lot when working with the two languages. With Node.js, there is a lot of support, a lot of SDKs already pre-built for this, so it's really easier to work with when trying to integrate external tools. But with Spring Boot, it's not really the same. So you need to determine if you want to actually deal with the hassle of implementing APIs by yourself and testing them by yourself, or you just want to go straight into implementing using the SDKs from the developers. So this is really something important for you to really analyze and take into consideration before picking your language. So from these little steps, you can already see why it's very important not to go straight into coding and actually take time to determine all these things before you get started. Because if you're going straight into coding, you can do the wrong choice, and in order to come back, you have to maybe start back your project and go back maybe to designing from scratch, which is something unwanted. You're better off if you design before you start building. So next thing you need to do is to accurately describe how data is going to flow in your application. So you need to use flow diagrams in order to do this. This is an example of a data flow diagram. I use this a lot when trying to visualize how data is going to be transferred in my application, because as I said, before actually writing the first line of code, you need to know exactly how your application is going to work in the back. If you go directly to writing code, you're going to miss out on a lot of stuff, and you'll find yourself having to redesign your backend every single day or re-implement stuff every single day. Whereas before you write your first line of code, if you take your time to plan, draw all the data flow, describe everything that's going to happen, you are not going to spend so much time coding. I know a lot of solo developers out there who don't even know about designing data flow diagrams. So today you know, and I recommend doing more research on this topic so you can actually know how to build data flow diagram. You can actually know what the different shapes mean. So the next thing you need to do is to create a use case diagram and user stories. So for most applications, you usually have two types of users. You have the normal user, you have the admin. So depending on your kind of application you're trying to build, you can have several kind of users, and all those users should have different permissions. So the use case diagram is going to give you a picture of what user has permissions to which service or access to what part of your application. You don't want the user to have access to your admin section, and you don't want, let's say, another kind of user to have access to another kind of part of your application. So design the use case diagram. It's going to make you understand the requirements of your app, so that once you start coding, even at the onset, you can already define a class, or you can already define a method that gives everybody permissions to certain services. So you will not need to be doing that at the end, and you will not need to figure out at the end how to structure this in case you didn't design it at the start. So designing all this at the start, setting your use case diagram, helps you determine how to actually structure your code in order to give the right entities the right permission to the different services in your system. So the next thing, you basically need to design your database. So before designing your database, you first of all need to look at the requirements of your project and determine if you want to go with an SQL or no SQL database. And this is a very critical question because depending on what kind of project you have, you may not need an SQL database, and depending on what kind of project you have, you may need an SQL database. In a case where entities in your database will need to have server relationships, I highly recommend you going with an SQL database. And in a case where the entities are quite loosely coupled, where you don't need server relationships, you can go with a no SQL database. So when you determine if you need an SQL or no SQL database, you can go and start designing your entity relationship diagram. And this is most especially useful when you're going with an SQL database. Without an SQL database, you must not design it this way with the relationships and all, but still designing how your data is going to be structured in your NoSQL database is good. So in your entity relationship diagram, you're basically giving or defining the relationship between the database, whether they have a one-to-many relationship, or many-to-one or one-to-one relationship. Determine your primary keys, your secondary keys, how they are going to do to communicate with each other, how the data is going to flow. You really need to design this before actually going to write any code, especially for SQL. In SQL, always design your entity relationship diagram before you start coding, because any mistake you do in the actual logic, your data is going to be impossible to access, your queries are going to be slow, and it's just going to be not a very fun time. Your app is not going to be very good to use. So designing the entity relationship diagrams is the next thing you should do. So finally, after doing all that, you probably need to also determine a way to store files. For example, if you need to store images, if you need to store other files in your backend, you have to determine what storage you're going to use. There are several options here. You can use local storage. That is, you use the local storage of the server where you're going to host your application. You can use cloud storage. There are several cloud storage services like Amazon S3. You can also have Firebase storage and so on. You can also use a CDN, even though a CDN is not a total replacement of these two different types of storage. But a CDN, or content delivery network, basically helps you distribute your images in several servers or data centers, so you can easily serve it back to your clients without a lot of latency. So you really need to determine how these images are going to store. I always like going directly with cloud services. So I mostly use Amazon S3 and Firebase storage. Those are what I use. I don't really use local storage a lot, but you determine what is suitable for your use case before actually starting to code. And finally, how will you manage content on your app? You need a content management system. I highly recommend using a content management system that is already available online. One, because they are not really expensive. You can get away with a ton of users and a ton of data on the free versions. And two, you don't really need to go through the hassle of building it by yourself. You can still do that if you want, but I highly recommend you pick either a normal CMS or a headless CMS. Headless CMS, you have things like Sanity, Contentful, where you can actually just use their APIs and connect it to your database and visualize the data and actually do the CRUD operations directly on the CMS. I also heard recently that you can use WordPress as your CMS. You can basically pull it out from a Docker image and just integrate it to your backend. I've never done that before, but that's something that is actually great to know, that options like that are available and you can actually use that. So finally, worry about hosting later on. Don't start spending too much time determining what hosting provider you're going to use. You can do that later on when you're implementing your project or when you're even done. You must not worry about the hosting immediately. You can do that later on, but you can still worry about the hosting at any time, even before you start building. But I highly recommend not to focus too much on hosting. There are more important parts to be determined. And now at the end of it, when you're finally finished designing everything, doing a ton of research, now you can start coding. So you see that we've talked about building a full stack application, building a SaaS, without talking about coding even once. That is how important the planning and the research phase is when building applications. As a software developer, coding is your least problem. Coding is the least thing you need to worry about. I've not said it's easy, but it's the least thing you need to worry about, because at the end of the day, you still code. But building good software is different. Building good software is not just about coding. Building good software is about everything else. So as a solo developer, you need to know that you have to start implementing what you've designed at the end. Start writing code at the very end, when you've already figured out everything, or when you already know how everything is going to work, all the data is going to flow, and so on. Thank you so much for watching this video. If you made it to the end, congratulations, because now you know exactly what steps to take in order to build your next full stack application. So let me know in the comment section if you want to see more raw videos like this, where we provide straight value on software concepts, how to build apps, how to optimize your apps, and so on. I have several other interesting videos coming up, so stay tuned, like and subscribe, and see you in the next one.